And welcome back, everybody. And today I'm going to revisit this Yale 1275 classic brass cladded padlock. And if anybody has bit codes on these locks, it would be a nice asset to have because these locks, these 6 tumbler locks, can be quite cumbersome to try to pick, and I couldn't pick it. And what I discovered was early on, before when I wrote my first book, The Extreme Antique Padlock Collector, that these locks can be decoded using a tumbler trapping technique that I invented. Here's the tool for that right here. So the problem with this lock, yes, it has an original key, is that it has a broken lever tumbler spring. And that will always bother me, even though this has a really nice patina to it. Well, surprisingly, I given up on this lock, and I got this in the mail just the other day. And after 8.5 months of waiting, it magically showed up. This lock was received in the lock position, and I decoded the lock. But here's the problem, guys. If you're going to cut an original key blank, or if you're going to machine your own blank, people often ask me, what happens if you cut it wrong? And I don't want to be wrong. I certainly don't want to spend hours upon hours, practically a day, to manufacture a blank and then not have the key work. So what would really prove the accuracy of my decode would be to get the lock picked open, because once it was picked open, you can revalidate or validate the position of the lever tumblers in respect to the key pin. And by the way, just as a reminder, you always want to take your measurements of decoding at the 11 o'clock position in respect to the key pin. So I got this lock open, and I didn't quite use a classic barrel key. And I did another technique that I invented, I want to say about 5 years ago. And I either posted the evidence of that either at lockpicking101 or keypicking.com. So I always had it in my thoughts that wouldn't it be nice to be able to open these locks similar to the way you open a champion padlock, champion pancake padlock. Well, the problem with that is there's no slit at the bottom, but there's a slit at the top. And that's really all you need. So check this out, guys. This is what I made right here. This is made from .018 spark plug gauge gap material. And the way this works is you insert this on the side and you push up and it locks in place. And that's it. Now the key is ready to be, I should say the lock is ready to be opened. So, well, you can't turn this, but it turns out this manufacturer put an interesting profile on the cam itself. That's the cam plate is below the last lever tumbler. And this is kind of a drawing the way that looks. Here is the opening of the keyway, and this is the open area surrounding the keyway. And this is all brass plate right here. So the key would sweep around this and make contact. Well, there's a place to make contact. So what I did was I just took a piece of wire and I pressed it up against this and pressured this as I lifted my tool. And that worked out quite well. So yeah, I got the lock open using this technique that I invented. And I think it's quite clever. This is the kind of thing that you simply won't see at other picking sites, guys. This is the real deal. This is the underground level of lock picking and key making that you're just not going to see in other channels. So the next process is to now make a key for this lock, and I'll make that out of bronze. And that's another project to do in the near future. And yeah, it's a process, guys. And Now I've got the correct and validation of my decode, and I won't be wasting hours when I go to cut my blank. I hope you enjoyed this video, and once again, thanks for watching.